Okay, so we have a line shape, we have an absolute value shape, we have a parabola shape which has a vertex and some counts. Okay, now we have a square root parent function. Now we have a cube parent function. Okay, these dots represent that I've got some count numbers. Okay, and we have a cube root. Okay, you have to pick the right shape based on the equation. This is a square root, so I'm going to make a note. It's that shape. Now this one, a little different. This one, it's a square root, but I see that negative, so I'm going to give myself a little reminder. That's the general shape of the graph I'm looking for. Okay? This transformation is left 3. That's it. There's my starting dot. Left 3. Now I have to count my points. Now memorizing these, I know them. 0, 0 is where we start. 1. And square root of 1. 4. Square root of 4. 9. Square root of 9. 3. Those are my x's and my y's. I'm going to plot whatever fits. 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 3. Okay, now if we solve graphically, it's a good bet that you're going to have to solve one of those points they're going to cross at. Okay, so this one is stretch by 2. It is a reflect over x, and it's up 4. Okay, up 4. 1, 2, 3, 4. Negative 2. I have the general shape. Now, that negative 2 means, okay, 0, 0, 1, 1, 4, 2. Negative 2 is my stretch, and so I'm multiplying. 0, 0, 1, negative 2. 4, 1, 2, 3, 4. Your solution is x equals 1. Look at how many variables do you see to start? 1, x. The only variable is x, means the answer is x equals. So 1 intersection. I turned it into a graph to help me guess or estimate the solution. It just happened to work out that it was an integer. What do you do graphically? You put both sides in the equation and you look to where they cross. Except this time, my starting equation only has x, and so my answer is x equals. Okay, my next one is a cube. That's the tall one. Cubing is the tall one. Cube rooting is the short one. So negative. So that's going to look like this. Think of your end behavior, guys. That's a negative leading coefficient and an odd power. Means it's going to look like a negative slope. Negative slope. That's what the negative does. Cubing. So this is left 3. So my cube numbers, I'm going to come down here and do it. 0, 0, and I am cubing. 1, 1, 2, 8. 327 is unlikely to fit on the graph, okay? But it is stretch by 1/4. It is reflected, and it is left 3. 1, 2, 3. Okay, 1/4, so negative 0.25, negative 2. Let's see, 27 over 4 is a little less than 7. Okay, maybe it does fit on the graph, right? Stretching or compressing by 4 does make that number smaller. Okay, so over 1, yes? Okay, so down 1/4, over 2, down 2, over 3, down 3, 6, and a little bit. Okay, I'm going to count the other direction. Because remember, cubes, negatives stay negative, which means you have both directions. Notice the square root graph is the only graph with an endpoint. Everything else has 2 arrows, both directions. Okay, over 2, up 2, over 3, up 6 1/4, and connect. Okay. There's my cube graph, tall. Look at my arrows. My arrows are pointing up and down. They're not like sideways looking. They're up and down looking, like a polynomial. It's because it's cubed. Looks like a polynomial. Okay. Oh. Line with a negative slope. Mx plus b. So down 3, negative slope. Down 3, negative 1 slope. And so this particular one crosses 3 times. 3 times. X equals 1, 2, 3, 4, 5. X equals negative 3. X equals negative 1. Happens to cross 3 times. 1, 2, so there's 3 solutions. Would I do this algebraically? It'd be kind of long and tedious.
Are they considered imaginary?
No. So when you solve them graphically, you will only find real solutions because they have to appear on the graph. Okay. Last one. I've got a cube root. Notice the first thing I'm doing is I'm picking my shape. I've got a square root. Okay? So this is left 1, and that's it. So left 1. So my counts don't change. Notice to get my count, all I'm doing is I'm listing out my perfect cubes in the right order. 8 cube rooted is 2. 2, 4, 6, 8, 2. Here. Notice my 3 dots. They make a nice slope line of 1. Those 3 dots in the middle give you a little hint as to what the A value is. 2, 4, 6, 8. So this is kind of far out. Okay. This is also left 1. 0, 0, 1, 1, 4, 2. 4, 2. 5, 6, 7, 8, 9. 3. Now, I did that 9, 3 because you can tell that the square root graph is getting bigger faster than the cube root graph. Like, they're not going to cross again. Okay?
Just making sure. So you only plotted those 3 numbers to find out what the number which is off the thing.
Yeah, Jake, if you only plot the middle 3 dots, 0 and 1 are on almost every single parent function. So you need a 3rd dot to differentiate the shapes.
And negative 2 is going to be negative 1 because the cube root of negative 1.
Correct. I don't like to write these because then I'm just making a really long list. I just know the cubes go both. That's why I picked my shape. I know I've got both arrows, and I just count them in the right direction.
And so how do you determine that that's like just because you know that it's cube root and it's going to be positive?
Yeah.
And how many points do you want them
Oh, whatever fits on the graph. Usually the cubes you only get about 4 points because if this one fits, then this one is off to the side somewhere. Okay, so solutions are x equals negative 1, x equals 0. Guys, there is no other points. I know they look very close, but you could check. What is 1/2? Let's go. What's 1/8 cubed? 1/2. What is 1/4 square rooted? 1/2. They're not the same numbers.
I have a question. On those, are we just going to get pretty much just integers?
Yes, you would. If I'm going to ask you to do it graphically, they're going to appear on those points that you're supposed to be plotting. Yeah. Depends upon where the other graph is. In this particular case, I lined them up so they crossed more than once. But no, they don't have to. Could I draw a cube root graph? And a square root graph? That only cross, yeah. They might be extraneous, which you don't know algebraically, but you would recognize graphically because extraneous won't show up on the graph. Yeah.
And if it was negative, then it would be like that.
Yeah. Okay. We're gonna go ahead and do. We've got 25 minutes. Okay. Go ahead and copy question 1 onto the back of this paper. We're going to do it algebraically. I mean, we can see the answer is x equals 1. Okay? Well, we're going to do number 1 algebraically. So go ahead and copy that onto the back. Root x plus 3 equals negative 2 root x plus 4. Okay. How would you? It's one of the last things we looked at.
Square it.
Square it. Okay, sure. Squaring it would undo some radicals. Let's try it.
Is there a simpler way?
Nope. Okay.
Mine's literally the best. You get x plus.
So we get x plus 3. Okay, you gotta be careful, guys. Your exponent property says distribute with pluses. So this is a squared, 2ab, b squared. Sometimes with two radicals, there's not a way to avoid foiling, but pick an easier choice, right? At least I don't have two radicals on the same side, just one radical. Okay, now I am going to change something. I really don't like that leading negative. Okay, I'm just going to make it, I'm going to do that. Okay, positive 4 and a minus 2 root x, because that leading negative, just if I can avoid it, I'm going to. Okay, I would much rather square that instead. It just looks nicer. Okay, and I'll go slow. I'm going to write it out twice. Because one of our common mistakes is you're choosing the right thing. You're choosing to square, but then you're not squaring it correctly, and it's kind of throwing off the rest of your work. Now, we already know the answer is 1. We found it. But now let's see if we can do it algebraically as well. Okay, first, outer, inner, last, we're adding and subtracting. Do you have any like terms? Yes, I have 2 like radicals in the middle. Okay. Okay. All I did is I undid 1 radical. I still happen to have a radical that's left. Well, try to undo that radical. So, yes, let's square it again, but before I square, I see some like terms that I should combine. So, I'm going to actually move this over because I prefer positives in front if I can do that. And I'm going to subtract the 3.
3x plus 2.
So that's a 13. And I'm going to subtract. Okay. I just combine my like terms with a positive in front if I could do that. Now, should I divide by 16 or not?
No.
No. No.
No, not really good idea.
16 does not divide nicely with 3 and 13. So let's just leave it where it's at. Square both sides. Okay, careful on your properties. Right, when there is no add or subtract, you do get to distribute the exponent, but not when there is. Right, big difference here. Okay, so this is, yes, you can use a calculator, guys. Thank you. 256x 9x squared.
Plus 26. I mean,
Nope.
72.
Whoa, whoa, whoa.
Yep, hold on.
26X.
Hold on.
My bad.
Hold on. Here we go. I got you over here. First, so that's 39 and 39,
Oh, right.
78. Okay. Now, I get it. Those numbers are a little bit big. They're a little bit big. Okay, I probably wouldn't do that on a test. I didn't plan this one, right? But we do know it's going to solve nicely. How would you finish solving this? Yeah, guys, it's a quadratic. How do you solve a quadratic?
And then GC.
Yeah. Okay. 9x squared. I'll be honest, arithmetic is not my... I can do a lot of math, but man, arithmetic and we just sometimes we just don't get along. I know. But I can do it. Right? Now,
I'm sorry.
I'm looking at this. Yeah, 256 minus. Does it divide by 3? Do we have a GCF? Does it divide by 9?
Yes.
Actually, is it 169 13 times 13?
Yes.
That's a... It doesn't divide, guys. This is only 13 times 13. There's no divide by 3. This is it.
Ethan, you're wrong.
So, no, there's no GCF. The only numbers that divide 169 are 1 and 13.
165.
So, right? I'm pretty certain I'm not wrong here. Okay. How are we going to factor this? This is a good exercise. Factor it.
3 goes, no, 3 does not.
Yeah, there is no GCF.
This is a big.
Well, I'm going to just put this. Right? My number's either going to be 1 and 69 or 13 and 13. I'm going to try 13. There are not a lot of choices here. Guess and check. Pretty good choice here. And I'm going to try 9 and 1. Maybe?
No.
No? Okay.
Wait, what's 9 times 13?
So what is 9 times 13?
Wait, I know this.
120.
No, 117. Guys, you're missing the point. I don't know the factors. I'm just trying to figure them out. It's guess and check. 9, it's 1 and 9, 3 and 3. 169 is 1 and 169 or 13 and 13. There are not a lot of choices. So I picked one of them and I'm trying it. I'm checking my outer 117 and my inner 13. It's not going to give me 178. So pick something else. Pick something else. Okay? So let's try this. Well, what if we do 9 and 1? Oh, guys. Okay. What's the difference between 169 and 178?
9.
9. Okay. Check my factors. Look at what I just did. Look at what I just did. Look at your outer and your inner. Ooh. Okay. Got to both be negative. And so we get x equals 1. This is a good answer. 169 over 9. Oh, we only got one answer graphically.
It's 13 over 3. Oh, actually, no, that's
No, it doesn't. It doesn't reduce. Guys, you only got one answer graphically. So what happened algebraically?
You have to do like 1 and...
No, we're not wrong, guys. This is not wrong. You did not mess up. But what do you have to do? Check. Why do we look at things graphically? Because extraneous don't show up on a graph. Only real answers. Okay? So Okay, flip it over. Shh. Can someone give me an approximate decimal for that? Okay, so let's divide. Oh, sorry, 90. Thank you, 18. Okay, 18-ish. Close enough. Look at your graph. Look at your graph. What happens over here? They get further apart. It's not an answer. They do not cross over there. That's how extraneous happens. Is when you square these things, the negatives disappear. The whole bottom half of your graph flips up top. No negatives. Okay. When you square all of your negative outcomes, which would be in quadrants 3 and 4, and so if they would have crossed, right, this would have flipped up to match this, but not really, because the squaring changed the sign. Okay, this is extraneous. All right, what do you need to be careful with? Checking for extraneous. When do extraneous occur? When you have square roots. Okay, that's where we're going to stop for our graphing. If you have more graphing questions, you need to come to Warhawk time. We will talk about the extraneous next class. We will write down some conclusions about our solving. Okay, what I would like you to do now is pick up your solving circuit. You can work in groups. You can go in the hallway. It doesn't matter. If it says calculator, use a calculator, guys. Okay? Here you go.